Alright, hello everyone. So for this question, let's go ahead and determine for part 1 the orbitals used to form the bonds, and part 2 the bond angles in O2. Now here we have 4 different answer choices labeled A through D, proposing combinations of, or rather 2 combinations of orbitals as well as the bond angle if it applies. So let's go ahead and start with the Lewis structure of O2 just to understand the orbitals used and therefore the bond angles. Now, recall that oxygen has a bond preference of 2, which means that it prefers to have 2 covalent bonds as well as 2 lone pairs of electrons to complete its octet. So in this case, we only have 2 oxygen atoms, each with a 2 bond preference. So for the partial Lewis structure, the 2 bonds are going to be shared with each other. So the partial structure are the 2 oxygens in O2 double bonded to each other. So going back to the octet rule, to make sure that both oxygens fulfill their octet rule, 4 electrons are remaining for each of them. So in that case, those 4 electrons are going to be represented as 2 lone pairs for both oxygen atoms. So from there, our bond preferences have been completed and both oxygen atoms have a full octet. So this is the complete Lewis structure of O2. So now let's talk about hybridization. Recall that hybridization is dependent on how many quote-unquote groups surround the atom that you're focusing on. And when I say groups, I'm referring to 2 distinct categories, either electron pairs or atoms connecting to the atom of interest. So focusing our attention on either one of these oxygen atoms, we have 2 electron pairs and only one other atom connecting to the atom of interest. So this makes a total of 3 groups, which corresponds to sp2 hybridization. So both oxygen atoms have sp2 orbitals that are used to form the bond between them. And because they have an sp2 orbital, recall that they always have one p to p orbital overlap. And this is because of the formation of the pi bond or the double bond in between both oxygen atoms. So just to reiterate, our orbitals are sp2 to sp2 and p to p. So now let's talk about bond angle. Recall that a bond angle is defined by 3 atoms that make 2 bonds between all of them. So because there are only 2 atoms in total in this compound, bond angle calculations or determinations do not apply, meaning that our answer is option D in the multiple choice. For part 1, we have OSP2 to OSP2 and OP to OP, and for part 2, bond angle does not apply. So with that being said, thank you so very much for watching, and I hope you found this helpful.